So, that is my brief guide through common misconceptions about TPMs. Let's talk a little bit now about why enterprises in particular should care, because with this audience, that is what I expect most people are actually going to be looking at. So, why do enterprises care about trusted computing? First and foremost, TPMs are already in pretty much every machine that an enterprise has. Most enterprises are not Mac dominated, and in general, you've got to roll the dice on a server whether you've got it or not. But they're in pretty much all of the worker workstations. They're in pretty much all desktops. So there's not any additional cost to rolling out TPMs. Now, integrating TPMs into your enterprise, I will be very clear here, is not free. Turning them on, getting them to talk to your existing infrastructure, that does cost something. And in some cases, it's not trivial. But it's not like rolling out a smart card infrastructure where you've got to find a smart card vendor and buy all of the cards and hand them out to everybody and do all the integration with your infrastructure. And TPMs do give you a very good return on investment for security, because we can start moving things that today live in software, like my PKI keys that I use to access my email could conceivably be moved to hardware, which makes them a lot harder to steal. Anytime that I have trust in a machine that is based on my machine says it's good, and today, it might have a piece of JavaScript that runs, that determines whether or not you can access the VPN. I've got, the last time I tried to connect remotely, I got a piece of JavaScript that popped up and said, are you good or not? And then it promptly crashed my browser. But that's not really a trustworthy thing for me to believe. Whereas if I can move that trust down to the TPM, I have a lot more assurance that the person who's claiming to be a machine belonging to my enterprise really is. And also, I said before that TPMs are not tamper-proof, they're tamper-resistant, and for a lot of people who care a lot about tamper resistance, they really want hardcore tamper resistance. But let's be perfectly honest here, some is a lot better than nothing for a lot of purposes. And being able to say that all of the laptops in my enterprise don't just have encrypted hard drives, they have encrypted hard drives that are going to resist Joe Bob the thief who stole out a car. Yeah, sure, if you're dealing with major industrial espionage or international espionage, no, it's not going to hold up to that. But let's be honest, most laptops are not stolen by a major threat like that. And this is one extra layer of protection against somebody who wants to steal all of the data that your finance person happened to be carrying on their laptop when working from home. So earlier, I mentioned in passing the TPM's big benefits: authentication, attestation, and data protection. And hopefully we're pretty clear how each of these are really quite critical in most enterprise scenarios. For example, enterprises have a lot of places where they want to know the identity of machines on their network. Network access control is the most fundamental and the most obvious. Should a machine be allowed to connect to our network? Now, if I've got a corporate wireless network, do I actually want any machine to be able to connect, or do I want to maybe have two wireless networks and unknown machines only get to connect to the guest network? I can now have, if I know exactly which machines are connecting, an intranet wireless network that I can be assured is secure if only my machines can connect to it. We have audit trails. Maybe I want to know which machine this data came from. This is something that can come up in finance, can come up in healthcare, but anytime you've got data tracking, audit trails that actually involve, if I sign this data and then you sign this data, we know that it went through me and then it went to you. Maybe we don't know everywhere it went to in the middle, but you combine that with processes that talk about how data is to be moved, and suddenly you can start building something pretty solid, tracking where things originated. You can do authorization requests in a much more meaningful fashion. So if I've got the record of all of the salaries in my company, I might not just say you need to be somebody with a password from the finance department. You also need to be coming from a machine that belongs to the finance department and stays in their office. We have all of those cases where, so-and-so from, Veterans Affairs or Bureau of Indian Affairs or various corporations was, lost a laptop that was full of Social Security data or full of credit card data. Well, if you only allow people to access that data on desktops or on laptops that have constrained permissions, well, all of a sudden that gets a lot harder to do. We can start saying, and now if an adversary comes along and steals my credentials, they put a Trojan on my machine, so now they have a username and password of somebody who does have access to this financial information. They now also have to get direct access to that machine in order to pull their data down. It's not impossible, but it's a lot harder. It's an extra step. And we've also seen TPMs used as a smart card replacement, where instead of, our corporation, we tend to use smart cards to say, here is my ID and here's my private key that identifies me. The big publicized use case of TPMs today is PricewaterhouseCoopers, which rolled out user identification by machine. So they are using their TPMs as smart cards because each user has a laptop. It's the one they always use. It's the one they always log in from. Now, that machine is effectively that user's authentication token. So there are a lot of places where machine authentication can be very handy, and the TPM makes this actually pretty easy. Attestation is also good, not our last person. Something that enterprises care a lot about, which is, I want to know whether the machines on my network are in a good state. Should I trust them? And today, fundamentally, every enterprise that I've seen does this by asking software, can the software be trusted? Now, there's variations. Maybe I'm asking my antivirus if my OS can be trusted. Maybe I'm asking my Oval reporting tool what the configurations of the machine is. But fundamentally, if somebody has put a rootkit in my machine, they can forge any of that. That the software says the software is good, and we just trust that. We don't even know if it's the software on that machine that's saying it. So using a TPM rooted attestation gives us much more assurance. It's not perfect today. We can't interpret everything perfectly, but it's way better than what we've got now. For one thing, it's a lot harder for software to fake a good measurement. At least we can figure out what good measurement looks like. And you can't just replay yesterday's good measurement today. The roots of trust for measurement are below the level that a rootkit can interfere with. Now, rootkits are not the only threat we have to deal with. And the dynamic root of trust for measurement is a lot better for this than the static root of trust for measurement, because there exists something called bootkits that are BIOS threats that do, in fact, potentially take out your static root of trust for measurement. But at the same time, now you're having to attack your BIOS. If I've just got a Trojan on your machine that's taken out your Symantec, that's a completely different order of threat. Also, all of those machine authentication use cases that I just talked about, well, attestation is that plus state. So now I can start saying not just which machine is it, but what software am I running? So I can say, if I've got my finance machine that's trying to connect to the HR database, I can lock that down much more than I might be able to lock down, a machine that is used for MATLAB and Word and so forth. I've got a finance machine, it should only ever run finance software that we trust, and it's only ever going to run our gold image. Why? Because this is designed to be the high security machine. Well, then I can evaluate, and now I've got one more criteria so that I can even say, you can only, I might have 2 different boot states or 2 different virtual machines, one of which can access it, one of which can't, and I can tell the difference. And this is particularly valuable if we build from our hardware roots of trust for measurement up to some much more detailed software reporting tools. Now, this is not the default today. The default today is your root of trust for measurement, which I will talk about. It measures things like the bootloader, and the bootloader measures maybe the kernel. And that's usually where it stops. There's a few details. On Linux, I can do some fancier tricks. But if we deliberately move beyond that, it's never the default, but we can get what potentially is saying, is my antivirus good? And now, instead of today's scenario where we're just saying, hey, antivirus, is this machine good? I can now say, is this antivirus good? And then ask if the antivirus for its report. So I can establish trust in those higher level tools, potentially. It's not easy. But this will give us much more reliable reporting, and we can start giving those things like antiviruses tools where we now know that this report came from the antivirus on this machine rather than the one on that machine, and somebody's changed the machine name, which today is very much a threat. So not all of these capabilities are yet available, in large part because determining what the machine state is from the PCR values is hard. Not every kernel, like Windows, does not really give us tools for measuring applications into PCRs. There are extensions on Linux that do, but they're a pretty special case, and they're research wing. So there's some development that needs to happen before this really becomes enterprise-worthy, but the potential is available, and if we start rolling out the early stages now, if we start rolling out TPMs and start using the authentication, we can build up to some very nice functionality in the end. I am not familiar with any of the companies that do cryptographic hashes of software. Frankly, TPMs are a great place for them to be expanding into. I suspect that part of what we're dealing with here, and this is very common in anything having to do with trusted computing, is a chicken and the egg problem. The vendor doesn't support it because there's no demand. There's no demand because there aren't any vendors that they can just buy it from. Whoops. So the third thing is data protection. And here, TPMs are really not providing any new capability. Fundamentally, we can encrypt data today. We've got software. But this does give us noticeably more assurance than today's solutions. Today, if we want to do data protection with an extra tool, we're usually using a smart card. And for all that TPMs are cheap, they generally are noticeably more tamper-resistant than smart cards, as far as I know. I mean, I'm sure you could get high-security smart cards, but they're not the cheapo ones that most companies use. They are way more tamper-resistant than the software encryption solutions, most of which boil down to we're going to encrypt some key using a passphrase, and yeah, they're dictionary attack resistant, but I clone the hard drive, and I can just keep dictionary attacking it to my heart's content if I really want to. And the fact that the keys are tied to hardware means that an adversary can't just come along, Xerox my hard drive, or hoover up my data over the network, and use them to their heart's content. So this is a big improvement over today's software certificates and software keys, where we have a lot of companies. The user has a certificate stored on their hard drive. Maybe it's encrypted, maybe it's not. That putting it in the TPM makes it harder to use. Now, it's worth noting the TPM doesn't know whether a request to use a key came from a user or came from software that might be controlled by an adversary over the network. TPMs are very dumb. They don't get to evaluate your machine state. So an adversary who has access to your machine can use it. But the difficulty level is now raised, because now I have to be on your machine performing operations in real time on a rather slow piece of hardware. So this is, I now can't do a one-off attack where I yoink all of your data and then leave and then masquerade as you at my leisure. And I can't, and if I do log in and I have to be there in real time, we can now do a little more detection because you have to be there using it at the time you're performing the operation, so we have more chances to notice you. So, certainly not perfect, certainly not completely leaving you invulnerable to a remote adversary, but it is making life harder. So, in that particular Mongo hour and a half of talking, we've covered what a TPM is and what it does, what it's good for, and some misconceptions about the TPM and what the reality is like, and why the enterprises should care about them. It was a long time ago that we talked about what a TPM is good for, so just to remind you briefly before we start diving in more deeply, TPMs give us a root of trust for reporting and a root of trust for storage. They also have some limited internal storage, including both keys and data, and most notably these platform configuration registers that are specialty devices that will let us store state and verify them remotely. It gives us a random number generator, and it does give us things like signing and data protection that we can use for our own utility applications. They give us machine authentication, attestation, data protection, which I think I've talked about more recently. And so, that was the big fire hose of the morning. Does anyone have any questions before we move on to other trusted computing technologies?